This is Precalculus Homework 3-11. The general way to solve these problems is to combine logarithms on one side into one logarithm and then inverting the logarithm with exponentiation. Let's see how to do that in number one. In number one, remember that when we subtract the insides, this is the outside of the logarithm. When we subtract the outsides, we divide the insides. So this is going to be log. Notice that there's no base in either of these, so we assume the base is 10. And this is going to be log base 10 of, and then subtraction means on the inside we're doing division, namely 5 divided by x, and now it's all one logarithm. The right-hand side is still 3. That's just one of the properties of logarithms that we have. And then from here, I'm going to invert the logarithm by taking the same base that this is at, and I'm going to do exponentiation, say that this is going to be 10 to the power of log base 10 of 5 over x is equal to 10 to the power of 3. And all I'm going to do is move this equal to sign down here. And from here, we are going to cancel some things out. Cancel, cancel, cancel. And we're left with 5 over x is equal to 10 to the power of 3. And from here, I can rewrite this as 10 over 3 over 1. And I can interchange my diagonals. I think the way that I'm going to do this is I'm going to switch these diagonals. And this is now going to turn into 5 over 10 to the power of 3 is equal to x over 1, and x over 1 is just x. So there's my final answer. I think I can simplify that a little bit, because 10 over 3, that's the same thing as 5 over 1 with 3 zeros. And I can divide both the top and bottom here by 5. I can divide by 5, divide by 5. Am I running into number 2 yet? Not quite. And that means I'm going to have 1 over... Let's see. So dividing by 5 is the same thing as multiplying by 10 and dividing by 2, or dividing by 2 and then moving the decimal place. So dividing this by 2 is 500, and moving the decimal place is going to be... Wait, dividing by 5 is dividing by 10, multiplying by 2. So multiply by 2 is going to be 200. I see, okay. So 200. I explained that poorly. So dividing by 5 is really the same thing as dividing by 10 and then multiplying by 2. I think that you can agree that these are the same thing. So what I did first, I multiplied by 2, and that gave me 2,000, and then I moved the decimal place 1 to the left and made it 200. And I believe that's the answer that we're looking for. Let's check. 1 over 200 for number 1, 1 over 200 for number 1. Excellent. All right, and number 2, kind of same thing. We're going to convert these into one logarithm. So this is going to be natural log of, and again, we are subtracting the outsides, so the insides we're doing division. It's going to be x divided by 9, and this right side is still 4. Notice that this is really, natural log is the same thing as log base e of whatever. So the way that we exponentiate is by choosing a base of e. So it's e to the power of natural log of x over 9 is equal to e to the power of 4. I'm just going to move the equal to sign down here so the equation looks better. And then things are going to start cancel out. U and u are gone, leaving me with just x over 9 is equal to e to the power of 4. And I need to get rid of divide by 9. The way that we do that is to multiply both sides by 9. So multiply by 9, multiply by 9, and there it is. We have x is equal to 9e to the power of 4. Final answer, and box it. 9e to the power of 4, 9e to the power of 4. All right, number 3. It's a little bit hard to see what's going on, but I mean, there's technically parentheses right here that you don't need to write. And we're going to write this as one logarithm. This is going to be log base 6 of, okay, it's going to be, these are they all subtraction? Okay, I finally have an addition one. I really should have varied this a little bit more. Finally, some addition happening down here. I would like 50% of them to be addition, so you can practice the difference between both of them. But again, subtraction means we do division on the inside. So on the inside, we do division, negative x divided by 9, and this side still stays 1. We've combined it into one logarithm. Exponentiation, here we come. This is going to be 6 to the power of log base 6. Again, you're just matching this base. It needs to be this base down here. And exponentiation with 6 on the right-hand side as well. I'm going to go ahead and move this equal to sign. So there's our new equation. And then from there, things are going to cancel. U, and u are gone, leaving us with negative x over 9 is equal to 6. I mean, it's really 6 to the power of 1, but 6 to the power of 1 is just 6. And then we need to get rid of this negative and get rid of this 9. I can do that all in one step by multiplying both sides by a negative 9. A negative 9. When I do that, u and u are gone, leaving me with x is equal to negative 54 for my final answer, which I will then box. Negative 54 for number 3, negative 54 for number 3. And we're on to number 4. Again, combine these into one logarithm. I have log base 5, and again, subtraction means division of the inside. So I have a 10. I'm going to divide that with a negative 3x. That's on the inside, and the right-hand side is still 1. Time for exponentiation. As always, this is going to be base 5, again, matching these powers, or sorry, these bases. Let's go ahead and move the equal to sign down so it looks a little bit more natural as an equation. Time to start canceling things. U, and U are gone, leaving me with a 10 over negative 3x is equal to 5 to the power of 1, which is just 5. And I'm going to write the 5 a little bit higher because I can see that because I have a variable in the denominator, I'm going to want to go ahead and switch diagonals, and that only works when I have a fraction set equal to a fraction. So I'm going to go ahead and say that this is divided by 1. Time to switch. All right, so I'm going to do a little switcheroo. The 5 is going to come down there, so our new equation is going to be, I still have a 10, but now it's over a 5. The 5 switched places, and the negative 3x came up here. And oh, do you know what I could do? Okay, it's still divided by 1, but I don't really need that. Here's what I can do. You don't have to switch the entire term. I can just only pull that x and leave that negative 3 down there. In fact, that's what I'm going to do. I'm going to come back here and say, I still have a negative 3. Oh, I want to do this in pen, though. I still have a negative 3 that I left behind. I'm going to bring a 5. This is all being multiplied. And I'm only bringing up the x. You're allowed to do that. You're only, like, if you have multiplication, you can only bring certain pieces up. When you have addition or subtraction, you have to bring the whole term up because it's essentially distribution when you're cross multiplying. So from here, we can now say that this is going to be 10 over negative 15, and we can divide by 5, divide by 5, and I'm going to get 2 over negative 3, or negative 2/3. So let's check. Number 4 is negative 2/3. Number 4 is negative 2/3. We got it. All right. What about number 5? Again, combine it into one logarithm, so it's going to be log base 7, and yet again, subtraction means division of the insides. I'm going to change this for next year. So I'm going to have x divided by x plus 4, and that's still going to be set equal to 1. Choose the base to be the same for exponentiation. 7 to the power of that is equal to 7 to the power of that, and we'll move the equal to sign down so it looks like an actual equation. Things to cancel out. U, and U are gone, leaving me with an x divided by x plus 4 is equal to 7 to the power of 1, which is just 7. All right, and then from here, yeah, there's no way to do a little trick here. You have to bring up this x plus 4. This x plus 4 just comes up here. There's no switching around, so that means I now have an x is equal to 7 times the quantity of x plus 4. Remember, x plus 4 is technically an entire term that we'll need to distribute the 7 into right now. So I'll have 7x plus 28 is equal to x. Let's get x's on the same side. I'm going to subtract 7x on both sides. When I do that, I'm left with a negative 6x is equal to a negative 28. And then from there, I'm going to divide both sides by negative 6, divided by negative 6. And that's going to give me x is equal to negative 28 over negative 6. Negative divided by negative is a positive, so it's really a positive. And I can reduce because I can divide by 2, and I get 14/3 for my final answer. Let's check. 14/3 for number 5. Oh, no solution. Huh. Why? I messed up somewhere. How did I mess up? Oh my, no. I was like, did I do 1 right here? No. What did I do wrong? 7 to the power of 1 is 7. I pulled the x plus 4 up here. Everything looked okay. What did I mess up on? Okay, let's start at the very beginning. Let's make sure I did this logically. They're both the same base, so you are allowed to combine them into one logarithm. Subtraction does mean division. I do inside divided by inside. Okay, everything right there looks good. And that's still set equal to 1. And then I exponentiate using a base of 7, and it's still 7 to the power of 1. That side looks good. You all do cross out. That looks good. I am allowed to use this trick because that's cross multiplication. I distributed okay. Yeah, I am not sure. That feels right. Is there some weird domain restriction that I'm not thinking about? Huh. All right, well, I'm going to show a cheaty method that I didn't want to show, but it's there's a bunch of cheaty methods. If you use a Desmos scientific calculator, it actually can do any base that you want, I think. So let's just log, is there can I do log base 2? I know it works on the normal calculator. You can do sub 2 Doesn't look like that button is here on this one, though. Weird. There's no, like, base B, which is probably for the best, so students have to do the change of base formula. All right, whatever. We're doing the change of base formula. Let's go ahead and see what the original problem looked like. Yeah, that's weird. So we don't need it to be that big. So this is going to be log of x, and that's all divided by log of 7. Log of 7. Why am I doing it on this graphing calculator? Now that I know that it doesn't have base B. Does it have base B? No. Hold on. I'm switching my mind. I'm changing my mind. I want to go to a scientific calculator since it's going to be easier to type because it actually has a log function. So log base x. Do we have an x? Log base x. I'm doing a change of base formula really quickly on u. So I'm just rewriting u as divided by log of 7. So we'll type in log of 7. Where's 7? 7. And then that's going to be minus log of x plus 4. So we'll say log of x plus 4. And that's all divided by log of 7 again. Log of 7. And let's go ahead and start punching things in for x. I said that if you say x is equal to 14 thirds. Oh yeah, it doesn't turn out to be 1. Interesting. So my work is incorrect. There's some sort of mathematical mistake. Did I do my change of base formula correctly? Yes, and yes. Huh. What have I done wrong? I was expecting this to show me a 1 on that top line, but it was negative 0.318. What am I missing? Cross multiplication, I get a 7. I do not know what I am doing wrong here. I'm going through all the steps once again. Is there something that I missed? I can show you a truly cheaty way in a sec. I'm just wanting to redo the math. You cross multiply, you have to distribute negative 6x. And oh, that was supposed to be a positive 28 there. That should have been a positive. Hold on, let's go back to the calculator. If I make that a positive 28, does that fix it? I bet it does. Split view with this. So check this out. I bet this is gonna work. Oh, shoot. Oh, that makes so much sense. Oh my goodness. All right, so, so I made only one tiny mistake, and it was right here, from here to here. That was my tiny mistake, and I really should have caught that earlier. I apologize. So sorry about that. Let's go ahead and change that. This is now going to be a positive 28, which means that this is going to be, we need to redo this area right here. That means that I have a negative 28 over a positive 6. Again, I'm going to still divide the top and bottom by 2, divide the top and bottom by 2, and I get negative 14 over 6, which is the answer, right? You're right, but here's the problem, and it's something that I didn't mention in the notes. I cannot, look, it's saying that this is the answer that should go into this x and go into this x, and I should pop out a 1, which seems okay, but the problem is logarithms do not work with negatives. If you give it negative fuel, it just doesn't work. This one is a little bit more, it would work over here because this plus 4 would make it positive fuel for the inside. This fuel, I shouldn't use the word fuel, but it's called the argument. This argument cannot be negative. This cannot be plugged into here. It's like getting down to the very end and getting 1 equals 0. It's the same thing. You can't have a negative answer and plug it into a logarithm. It's not in the domain. And if you're confused on what I'm talking about, let me give a brief explanation with a graphing calculator. If I type in log of x, log of, can I just do x like this? No, it doesn't like the square brackets. I need to do parentheses, log of x. You'll see Can I make it a little bit easier to see? Notice that this line, it does not go to the left. Like, there's no line over here on the left-hand side. It runs into a wall, and I wish I could... Here, can I take a screenshot so I can draw this for the screenshot? Let's go ahead and, you know, I just need this graph right here. So we'll copy you. There we go. So if I copy you and come back over here and paste. Do I have any room here? I'm gonna put it right here. Notice I can now draw on this thing. You can plug in 5 and you'll get an output. You can plug in 10, you get an output. You can plug in 2, you get an output. If I plug in -1, this line does not connect to our normal line anymore. This line cannot go any farther left. It can't go negative. You are never allowed to plug in a negative and figure out what height you're at. None of the values over here exist. You're never allowed to plug in negative fuel. It's how a logarithm works. So that's why the answer here is no solutions. So therefore, no solutions. My bad. I did not cover that in our lesson, and I will not put this on the quiz or the test since I didn't teach it in the lesson. Number 6. All right, much easier. Whew. It's not like the last problem. All right, so in this one, again, you're going to do log base 9 of, and then you're going to do subtraction. X plus 4, subtracting the outside is division on the inside, so divide by x, and that's all going to be equal to 2. And we're going to exponentiate. This is going to be 9 to the power of 9 to the power of, and from here we're going to cross, 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 leaving us with an x plus 4 over x is equal to 9 squared. And I'm going to treat this as like a fraction. I'm going to bring the x up here, so it's going to turn into this, I'll just do underneath, it's going to turn into x plus 4 on the left, and 81, because 9 squared is 81, times x, so 81x. Well, it seems like the right side has the x's, so let's bring this x over here by subtracting x on both sides. I'll say minus x, and I get 4 is equal to 80x. And then from here, I'm running out of room, but I'm going to divide by 80, divide by 80, you're gone, and x is equal to 4 over 80, which I can reduce by dividing both the top and the bottom by 4, divide by 4, and I get 1 over 20 for my final answer. And I'm always like in the back of my mind checking, can I plug you into x now? Yes, I have positive fuel, so I am allowed to plug into x. I'm always going to be thinking about that for like the next, I don't know, hopefully the rest of my life, because you're always supposed to check that. You're supposed to plug in your answers and check your work. If we had checked our work, well, we made a mistake over here, but if we check our work every single time by plugging it in, sometimes the calculator will be like, no, you used negative fuel. All right, number 7. Log base 6. Now we finally have addition, which means I'm going to multiply u by u. So I'm going to multiply 5x plus 3. That thing is going to be multiplied by 4, and that's all inside the logarithm. And then over here, I have, oh, this one is interesting. I have a logarithm, log base 6 of 67. I like this problem. It's kind of a, you don't know what to do, and it's actually easy to do. So I can simplify the inside. This is going to be distribute. It's going to be 20x plus 12. And then I'm going to have log base 6 of that, and this is still log base 6 of the 67. And the exponentiation is my favorite part. I have a single logarithm on the left, single logarithm on the right. You're allowed to use exponentiation with single logarithms. So I'm now going to say, what base? Well, base 6, right? So I'm going to say base 6 and base 6. I've done my exponentiation to make this equation look natural. I'm putting this equal to sign down here. A ton of things are going to cancel out. Check this out. You're gone, you're gone, you're gone, you're gone, you're gone, and you're gone, meaning 20x plus 12 is equal to 67. Everything is gone except for like the basic equation. Let's go ahead and solve really quick. Minus 12, we get 55 is equal to 20x. Then we're going to divide by 20, divide by 20. X is equal to 55 over 20, which we can reduce, divide by 5, divide by 5, and we get 11 over 4 for our final answer. Number 7, 11 over 4, 11 over 4. Number 8, All right, another subtraction problem. Subtraction on the outside means division on the inside. So still log base 3 of x plus 2 divided by x plus 6, and that's all going to be equal to 1. All right, exponentiate, ready, set, go. Base 3, move the equal to sign down, and we're going to cross some things out. You're gone, you're gone, you're gone, and I get x plus 2 over x plus 6, that's supposed to be a 6, is equal to 3. And just like before, I'm going to go ahead and bring all of you up here on the diagonal, and my new equation is going to be x plus 2 is equal to 3 times the quantity of x plus 6. Time to distribute. 3 times x and 3 times 6 is going to be 3x plus 18 is going to be equal to x plus 2. Let's get x's on the same side. So I'm going to work up here. I'm going to move the x's to the left-hand side. So I'm going to have 2x on the left-hand side. What I did was I subtracted x, and that's going to be plus 18 is equal to 2, and then we're going to do subtract 18, and we get 2x is equal to negative 16, and then from there divide by 2, and x is equal to negative 8. Let's check it. Negative 8 for number 8. Dun, dun, dun. Wrong answer. Sir, you made another mistake. And where did we make it? And besides, would this even work? We have negative fuel. Negative 8 minus the 6 is even more negative fuel. That is impossible. There's obviously a mistake here. I did go pretty fast. Let's go ahead and slow down. You are copied down. Incorrect. You're the problem. You right there. We're supposed to be a minus 6, and I put a plus 6. Why did I do that? I don't know. So I have to do minus 6. Oh my goodness. If you caught that mistake, again, you should be logging it. Minus 6, that might be one of many mistakes. So minus 6, which means this is a minus 18, which means I'll have a minus 18 here. And I'm just going to redo all of you. I have a minus 18 here, which means I'm going to add 18. I'm going to get 20 is equal to 2x, divide by 2, x is equal to 10. I think that was the answer, right? 10? Whew. All right, that was a tiny little mistake, but you can see that it really causes a lot of issues. So go slower, kids. Don't go fast like Mr. Sindel. I did number 10 in class, but I'm going to go ahead and do number 9 and 10 again, just to make sure that we're on the right page. Log base 4, all right. Log base 4 of, okay, there's addition happening on the outside, which means multiplication on the inside. So 5 times the quantity of 8 minus 4x. I didn't really need the dot right here. There's no symbol, you assume that's multiplication. I do need to distribute 5 times 8, which is going to be 40, and 5 times negative 4x, which is negative 20x. And this is still log base 4 of all of that stuff, which is equal to 3. Time for exponentiation, we're choosing a base of 4, move the equal to sign down so it looks like an actual equation, and cancel some things out. You're gone, and I have 40 minus 20x is equal to 4 to the power of 3, which I can do a little bit faster. 4 to the power of 3 is 64, I think. Let me check. 4 times 4 times 4, 16, yeah, 64. All right, got it right. And then from there, I'm going to subtract 40, getting the constants on the right-hand side. I get negative 20x is equal to positive 24, and then I'm going to divide by negative 20, and I get x is equal to negative 24 over 20, and I think they will both have a 4 in them, don't they? Divide by 4, and I can get negative 6 over 5, negative 6/5, please. Number 9, negative 6/5. Woo, let's go, negative 6/5. All right, last one, number 10. Same thing as before. Combine them into one logarithm. Log base 2 of 5, and then that's going to be divided by negative x minus 1. I don't like writing them on the side like that because you can't tell where the fraction actually ends. So I'm going to say 5 over negative x minus 1 like that. There we go. That's going to be equal to 1. Again, exponentiation incoming, base of 2, time to cross. You're gone, and I have 5 over negative x minus 1 is equal to 2. And then from there, I'm going to just bring you on up to this side. I'm going to get 5 is equal to 2 times the quantity of negative x minus 1. Time for distribution. 2 times negative x is negative 2x. 2 times negative 1 is negative 2, and that's still equal to 5 on the left-hand side of the equation. From there, we're going to add 2 to both sides. Add 2, and I get 7 is equal to... 7 is equal to negative 2x, and when I divide by negative 2 divided by negative 2. I get x is equal to negative 7 halves. Please be right. Negative 7 halves for number 10. Negative 7 halves for number 10. That concludes homework 3-11. I apologize it took me so long to figure out what was going on in number 5, but hey, we learned from that mistake, and we know never to plug in negative numbers for logarithms. Thanks for watching. I'll see you guys later.